Hello students. After the topic of alkenes and the isomerisms in alkenes, now we switch over to the another portion is the preparations of alkenes. Alkenes can be prepared in the laboratory by a various method. In our NCERT textbook, they illustrate the first method from alkynes, means from triple bond. In short manner, when alkynes means having a two pi bonds, on partial reductions, mind well, is not a complete reduction but partial reduction. If we particularly perform a complete reductions, then it can be converted into alkane. But we have to stop up to alkene. That's why we have to take a hydrogen in a calculated amount. So this is called as a partial reductions. With the help of dihydrogen in presence of palladized charcoal, means palladium in presence of carbon, partially deactivated with the poisons like sulfur compounds or quinoline, gives alkene. But mind well, this particularly alkene is cis in nature. In our earlier session, in the case of isomerism in alkene, we have to study that there are two types of isomers that can be seen in the case of sp2 hybridized alkene. One is cis and remaining is trans. But mind well, in this method or from this method, we can get cis alkene, not a trans alkene. This palladium carbon is also called as an Lindlar's catalyst. The name is called as an Lindlar's catalyst because it can be inverted by Lindlar's, or sometimes it's called as palladized charcoal 2. Charcoal 2. What is the meaning? Why the purpose of carbon in the catalyst palladium on carbon? Because some students says that why carbon is necessary in this process of a Lindlar's catalyst. So here there are some reasons, because as we know that palladium, platinum, right, are very expensive. So the finely divided metal is oftenly mixed with inert materials. These inert materials having a high surface area such as carbon black. When we studied about the alkane, at that time there is a carbon black is formed in the case of combustion, right? This carbon is called as a solid support and dilutes the catalyst as well as increase the relative surface area. That's why we have to take a carbon with palladium is called as a Lindlar's catalyst, and the role of this catalyst, there is no role of carbon but the role of palladium, but they support the reactions. That's why we have to take a palladium carbon. Okay, sometimes palladium calcium carbonate is also used to form a cis alkene. Now the another portions, when alkyne partial reductions in presence of liquid ammonia with the help of sodium is converted into trans alkene. Okay, so by this method we get a cis alkene, while with the help of this sodium in presence of liquid ammonia is called as a trans alkene. This method is sometimes called as a Birch reduction 2. In our NCERT textbook, they cannot particularly give the title, what's the name of this reduction, but mind well, it's some most important reactions in the case of JEE main as well as advanced students. It's called as a Birch reduction, right? For example, what is the basic or what is the little bit mechanism that we have to see in the case of Birch reductions? If we have a alkyne, as we know that these pi electrons are very rich electrons because they supply the electrons. Sodium having a nature to lose electron, so they get the electron. Now the sodium is converted into sodium plus, while this sodium when it's a one type of reactions. In this case you get Na plus, right, because sodium lose electron Na plus. Now this carbon having a 2, because this pi bond is converted, or this can be these electrons which can be shifting towards to this carbon, so is a carbon anion or carbanion, and it's a carbon electron, right? Now it further reacts with ammonia, so at that time they lose hydrogen and NH2 minus. So now Rc, okay, they have, because they lose H plus, so this H plus which can be attached with this carbanion, and we get a certain type of a structure. Now this is further react with the sodium further lose one electron, and this particularly electron, it's a one type of free radical, now is converted into carbanion, right? The same scenario, NH3, so they lose H plus, and H plus is react with this extra lone pair of carbon and converted into this alkene, but mind well, it's in opposite directions, not in the same directions, right? Because here in this case carbanion on this carbon, and in the remaining case carbanion on adjacent carbon. That's why the addition of hydrogen on a opposite positions, so we get a trans. While in this case Lindlar's, in the case of Lindlar's catalyst, right? In the case of Lindlar's catalyst, we get a cis, because they directly attack on the same side. So this is all about the Birch reduction. Okay, fine. So it's a mechanism of Birch reduction. So what about the Birch reductions? So in this case we get a different two types of product. Okay, now our next topic is a from alkyl halides. Sometimes this reaction is also called as an dehydrohalogenation reactions or beta eliminations reaction. The meaning of eliminations means we have to remove. So in this case we have an alkyl halide. This is alkyl halide, CH3, suppose CH2Cl. Okay, on heating with alcoholic KOH, means what is the meaning of alcoholic KOH? Potassium hydroxide dissolved in alcohol is called as an alcoholic KOH. This alcoholic KOH, say ethanol, which eliminate one molecule of halogen acid and to form an alkene, because what they particularly here in this case, removal of X and removal of H, so it's a removal of HX. That's why the name of this reaction is called as an dehydrohalogenation reactions, or it's a beta eliminations reactions. Okay, so it's a removal of halogen acid. This is the example of beta eliminations reactions. Why beta eliminations reactions? Because hydrogen atom is eliminated from the beta carbon next to the halogen is attached, so it's sometimes called as a beta eliminations reactions. Once again, alkyl halides on heating with a strong base, mind well, this is a strong base such as KOH. For example, if a person who says that in place of KOH we use a certain type of a weak base, no, here it's required only strong base, such as sodium ethoxide is also used. Sometimes sodium ethoxide means C2H5O minus Na plus, sodium ethoxide, right, is also used. So, or potassium hydroxide undergo dehydrohalogenation reactions and gives alkene. So, what is in these reactions? First, your potassium is connected with hydrogen, and the removal of this beta hydrogen is react with a OH, so it's converted into KiH2O, and there is a pi bond between this carbon and carbon, so we get a product CH2 double bond CH2, it's the ethene. So there is a removal of iodine from alpha, removal of hydrogen from beta, that's why it's a removal of HI, that's why it's called as a dehydrohalogenation reactions, and removal up to beta, that's why it's a eliminations or beta eliminations reactions. Right? This process of removal of a molecule of a halogen halide from a haloalkane form an alkene is called as a dehydrohalogenation reactions. Right? Now the ease of dehydrohalogenation. So the ease of dehydrohalogenation reactions for a different alkyl halide having the same alkyl group but different halogen is called as an iodide, bromide, chloride, because removal of iodine compared to the bromine in a speed way, okay, because the size of iodine is quite good, so quite high, so the bond is little bit weaker, so it's a removal of iodine compared to the bromine and compared to the chlorine. So the rate of reactions to remove beta eliminations reaction, iodine is fastly removed or eliminated compared to the bromine, and bromine is completely far better than a chlorine. So this is about the ease of dehydrohalogenations for a different alkyl halides having the same alkyl group but different halogens, right? While for different alkyl halides having the same halogen. So in this case, tertiary is quite good compared to the secondary, because tertiary, in this case, we get a tertiary carbocation is your intermediate, and as we know that tertiary carbocation regarding to hyperconjugation is more stable compared to the secondary, and secondary is more stable than primary. So we get such a type of a scenario, okay. For example, if we have a CH3 CH2 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 Cl, so this halogen containing carbon is called as an alpha carbon, and adjacent carbon of alpha is called as an beta. There is a removal of chlorine and removal of hydrogen from beta, so it's a removal of HCl, and we form a pi bond in between, so we get a butane as a product plus KCl and plus H2O. But what about in this case? Mind well, it's an interesting case. CH3, CH2, CHBr, CH3. As we know that in this alkyl halide, bromine containing carbon is alpha in nature, while the adjacents are beta in nature. So there are two beta. So there are two different possibilities. At presently, there is a removal of hydrogen from this terminal methyl, and the removal hydrogen from this methylene carbon too. Okay, when we react with KOH in presence of alcohol and give the certain type of heat near about 80 to 90 degrees centigrade temperature is required. So if the bromine is removed from the alpha and hydrogen removed from the CH2 group, so we get a product is like that. The name of this particular group is butene, right? Butene. 80% product we get, okay. But there is another possibility. If a removal of bromine from alpha, but the removal of hydrogen from this terminal methyl group, so we get a product is butene is only 20%. Okay, so what's the reason behind that? It's a very simple reactions, because it's a tertiary carbo. Okay, these particular reactions or the mechanism of these reactions through a carbocation. So in this case, definitely if we remove bromine, so it's a secondary carbocation. So in both cases, it's a secondary carbocation. But this secondary carbocation having two different positions, while this secondary carbocation having only one positions. So regarding to butene, so how many hyperconjugative structure? 3 plus 3, 6 plus 1, 7 hyperconjugative structures. While in this case you are having a double bond, mind well, okay. So 2 plus 1, only 3 hyperconjugative structures. So 7 compared to the 2, so it's a highly stable in nature. That's why we get a butene. But it's a detailed answer. But there is one scientist whose name is Rajeev. So it's sometimes called as Rajeev rule. So depending upon the structure, alkyl halides may give one or more isomeric alkenes. In this case, Rajeev suggests that whenever two alkenes are theoretically possible during a dehydrohalogenation reactions, it is always more highly substituted alkene, because it's a more highly substituted alkene, means having a lesser number of hydrogen atoms on the double bond, which is predominant. So here in this case, it's a predominant, and it's a minor product, it's a major product. So this is all about the Rajeev rule. But in the case of haloalkane, when we move in the lessons haloalkane and haloarine, at that time we have to having such a detailed idea about the why this particular eliminations reactions, what's the versus eliminations versus substitutions reactions, nucleophilic substitutions reactions versus eliminations reaction, SN1 versus SN2, E1 versus E2. But further in our our next journey towards to haloalkane and haloarine, at that time we have to discuss this topic in a very detailed manner. Thank you very much.